thank you everybody for coming in today, and I'm really honored to speak here. I've seen many talks and learned a lot of things, so I'm really excited to speak before you, and I hope you learned something from this. So let's get started. So today we're talking about NSQ, which is a message queue library, and it's something I've been using for the last year in the project I'm working in my job. So I want to focus today on how we can use it in Node.js and also in the Bash shell. So I'm Faustino. I work in OpenJAW Technologies here in Dublin. I also do a little bit of photography, and I'm from Portugal. So here's what we're going to talk. So we're going to talk a little bit about queues, about NSQ. We're going to have a demo in the Q&A. So a queue can have a few definitions, but the one really interested is the one about computing. So a queue essentially is a list of items, commands stored as in a retrievable in definitive order, usually in the order of insertion. So queues are a unified system where it used to emit and receive events. They are naturally fit for distributed architectures, allow real-time and batch or offline mode. They enable you to decouple from your code and from protocols you might be using, and they allow you to plug and play your kind of new workflows without changing existing application code. So there's a couple of patterns about queues. So there's the unicast kind of pattern where a single producer connects to the queue, sends a message. There's one consumer, gets the data, does something with it. You have the broadcast where a producer sends a message, and there's many consumers subscribing to that queue. They will all get a copy of that message. And then you have kind of a multicast where you have a producer that sends this message to groups of consumers. So a group of consumers, as you'll see in NSQ, is called a channel. Essentially, is a form of aggregating interest in this queue. So only one consumer in each group will receive the message. You'll see that shortly. So what is NSQ? NSQ is this message queue, and it's an open source project developed by Bitly. There's a few links here about the community in Google Groups and Freenode. They also are on Twitter. There's quite a few companies, and this has been growing over the last few months, who have been using NSQ. There's a few kind of big names in there. One that I know of, Halo, I think they're pretty much one of the first big ones, apart from Bitly. They use it as well. They use it mostly, I think, for offline, a kind of batch mode. They use other queues as well in there for real time. So in terms of NSQ, so its definition really is a real-time distributed messaging platform. It's designed to operate at scale, can handle billions of messages a day, has distributed decentralized topologies, supports this, has no single point of failure, is fault tolerant, and has high availability, and has a reliable message delivery guarantee. So that's what you read on their site. So I haven't really today came this to production where I can say I've done billions of messages a day or so, but you have to believe what they say. In terms of libraries and tooling, so they support kind of all the main languages you'd think of, and they have official drivers for Node.js, Go, and Python. So if you're using this in Node, you just install NSQ.js, and that's the official driver. I think there is another driver, just community driver. In terms of libraries, so NSQ essentially has the NSQD, which is the daemon that is going to read and write messages. There is a lookup daemon as well, which is used for service discovery. So for the producing and subscriber daemons to know about the other daemons, so they connect to this lookup, and then they can get information of where in the network the other daemons are. So they establish point-to-point connections. There is also a bunch of shell utilities that come in the release. We'll see those in more detail a little bit later. And then there's the NSU Admin, which is a GUI that allows you to create topics and kind of see what's going on in the system. We'll also have a quick look at that. So when you download NSQ, and because this is written in Golang, essentially you get all these binaries, and it's not very big. If you wanted to go package this in your application, you probably only take NSQD and the lookup and maybe the admin. So you're talking about 20 to 30 megabytes to put into your distribution. Then all the other ones, NSQ underscore something, they are mostly things you'd use for debugging or for operators in your company to connect to a queue and maybe extract some data. But you could also use it, all day long in production if you want to. So in order to start the daemons, essentially first you start the NSQ lookup. Then you start daemons and you tell them where the lookup is located. So you give it the IP. So if you're running this local, you use 127.0.0.1, and then the port. So the port for TCP for the lookup is 4160. There is also an HTTP port. Then if you want to start the admin, you would give it the lookup address as well. But in this instance, you give it the HTTP address. This is because the admin will do these lookups from your browser. So that's why you have to use HTTP. So how do you use this in Node? This is just a very canonical example of how you subscribe to a topic. So you'd require the module, create a new reader. You would say what topic you want to connect to, what's the channel you want to connect. Sorry, not to connect, but what is the channel that you want to be a part of. After you connect, then you start getting message events. And the message essentially has what you'd be interested in is a body property. There's also an ID, and then it has a few methods to either finish the message or to say, I couldn't do anything with this message, so kind of put it back on the queue. If you wanted to write a message to NSQ, you'd connect to a daemon, and here you connect to the daemon directly, not to the lookup. After you get your connection ready event, you would publish onto a topic and a message. Then you have a callback where you can see if there's any error, and if you want, you can close your writer. There's also an event for the writer being closed. In terms of shell, all those utilities we talked about in the beginning, they essentially let you kind of do hacky things, kind of stuff that operators normally would do if something is going wrong, or if you want to try integrate your existing queues into some other system. So, for example, if you wanted to stream to NSQ, there's this to NSQ binary. So essentially, anything that gets read from standard in will go into the topic. And here the topic, I'm just calling it standard in. There's also another one called NSQ to HTTP. So this one you will connect to a topic, and any message that comes on that topic gets posted into some URL, you say. There's an NSQ tail, which is pretty much like tailing a file. So you tail on the queue, There's an NSQ2 file, so if you wanted to save messages on the queue into a file, maybe you wanted to use that later on to try and reproduce an order of events, or just for backing up. And then there's a NSQ to NSQ, which allows you to do cross data center or cross queue kind of communication. So if you wanted to have maybe a queue for your application, and then maybe there's another queue for next generation of your application, you wanted to, you know, maybe send on some events from the legacy application into the new one, you could use this to NSQ. There is also HTTP API supported, so you could just do curl here, send some message into this NSQ daemon, and here you're using 4151, which is the HTTP port. You have to specify that you're doing a publish and what the topic you want to publish to. You could also send multiple messages. Default would be the new line separator, but you could define your own. There's a flag where you could do that. So if you're, for example, reading a file, you could read the file and pipe it in using this. So it kind of enables you to use NSQ and send data into your applications using normal Unix kind of tools. There's other endpoints you can see here, the kind of normal create and delete for topics and channels. There's also a pause and unpause. So if your system is under load and you just want to kind of hit the pause button, you can do that. There's a stats, a ping, and info. And this is the front end for the NSU Admin. So essentially you have this two main pages, the streams and the nodes. We'll see this working as well. So here's the demo part, and I hope everything works well. So what we're trying to do is we're going to read some text from standard in, and we're going to pipe that into that 2NSQ binary, which is going to publish into some topic. Then we're going to have the NSQ to HTTP listening on that topic and sending a post. And then we have a little express Node.js application that when it gets posted to will publish essentially kind of the same information into another topic. And then we're going to use NSQ tail on that second topic to see that coming through. So without further ado, and hope everything will work. So I pretty much have everything running already, but I will stop things and try and show what each one is. So I hope you can see. If you're having difficulty reading, just let me know, and I'll try and make the text as big as I can. All right. So I just have a little helper here. So the first thing we're going to do is this standard in into NSQ. So we're just going to read forever from standard in, and then echo whatever we read to pipe it into NSQ into that standard in topic. So let's just get that running. I already started the NSQ daemons and the lookups and the admins. I have that running already. So this guy is running, so whatever I type in there will go into as a message. So I'm also going to start the NSQ to HTTP. So that's the second part in that flow there. So that's going in, and now I'm going to start here my web server. So my web server, I'll just show you the code really quick. So the important part is this bit here. So whenever I get a post into this topic that I specify from the command line, I'm just going to log that into the node standard out, and then I'm going to send that into NSQ. So when I started the NSQ, the library, I start a writer using this NSQ writer, and the parameters I have to give it is what is the host and what is the port, and then I connect. So after I connect, then I can publish messages. So here I'm just sending, I want to publish into this topic, and then essentially what I'm doing is just sending a slightly different object, which sends in the body of this request. So that's it, and then I'm checking for errors. The rest is pretty much normal Express application. So I'm just going to start this guy, and so if we go back here, so we've started this, and this. Now I'm going to start the NSQ to HTTP as well. Oh, that's already started, sorry. And I need to do the last bit, which is the tail for the other topic. So this is the NSQ tail on the topic that the Express application is going to publish to. So I can put that in there. Then the other thing I can do as well, which is not on this flow here, I can also tail on the original topic. So this will show that I can have this kind of multicast pattern where the message is going from the to NSQ goes to the queue, and then a copy goes to the Express application. It goes to the NSQ to HTTP consumer, and then another copy goes to the NSQ tail. And just to give you a slight overview, this is the NSQ see if I can open up this here. So essentially the idea that we're trying to do, if you read the site, it's, well, better explained from what I'm saying, but this is what happens. So you're sending a message into a topic, and then all the consumers in a channel, only one gets the message at a time, but all the channels get that message. So that's kind of what we're doing here. So hopefully everything will work. So if I try something here, so I get this Express, for example, it's showing that there was a post, and this is the body. So essentially it's coming from the to NSQ here, and the NSQ to HTTP here is sending that the Express application listened. There's a tail here for the standard in topic, and then there's the tail here for the Express application, which is showing the message we were creating in the Express application. So my point here with this presentation is I don't have a lot of experience with message queues. I've tried to use some of them, and what I found about NSQ and kind of the takeaway from all this is that it's easy to use. There's good tooling around it, and it enables you to get things done quickly. It's easy to deploy. So from an operational point of view, I think it's much easier than having to, lots of dependencies, JVMs, and all this kind of a monolith of a message queue. The thing I forgot to show, the admin panel. So here, if you go to streams, you'll see there's a bunch of them. So there's the standard in topic, which we were sending initially. So here you can do, you can empty the queue, for example, if you wanted to completely wipe it out in case there was something in there you didn't want to get processed. You can delete the topic, pause the topic, and then you can see some information of which are the channels that are connected to this queue. So we have the NSQ to HTTP, which was the guy who was posting stuff to Express, and then we have the tail. That tail there is an ephemeral channel, so essentially after the connection finishes, that channel is deleted and nothing else will be sent to that. The other one is not ephemeral, so the NSQ to HTTP is not ephemeral. So what happens is, if the NSQ to HTTP wasn't running, when it started, it would get delivery of the messages. So the daemon would hold those messages for that channel until that channel came up. So there's a few statistics of messages that are in flight, deferred, reviewed, all kind of useful things you'd want to see. There is also a nodes. So here it's pretty simple. There's only my machine, but if you had multiple NSQDs running in multiple hosts, you would see them all here separately. But the interesting thing is that you can see, oh, on this host you have 4 topics, and these are the topics. There's also a little counter. So if you go to the NSQ Twitter, you'll see some guys sometimes post, and there's this last 2 weeks ago or something, there was this guy, and the whole thing was filling up the whole screen. The number of messages was like a few billion, I don't know how many it was crazy. But it's just a kind of a nice thing if you want to have on a big screen running, just to see it working, if everything is working. Then here's the lookup. So it gives you information about those service discovery daemons. So you can, in production, you should run about 3 or 5 of those, not just one like I'm doing here. And then when you connect your daemons, you give them the address of all of those. They don't communicate with each other, so it's not like a distributed system. A lot of these distributed systems that there's no like communication between them. The only thing they keep information of is which are the consumers and producers and the topics. And from here, yeah.
Why would you keep basically more than one lookup? It's just for redundancy, is it?
Yeah, just for failover scenario.
Just have like 3 or 4 releases.
Yeah, if they go down, essentially your system won't go down.
Okay.
What happens is that new daemons that come up wouldn't be able to discover the other daemons. But all the daemons that would be running would stay running, because after they discover the other ones, they connect point to point.
Oh, okay. Very good.
So there's no problem if the lookup died at some point. The other kind of interesting thing about NSU is that the topics don't have to be created beforehand. So I think some queues require that topics be created before something is published to it. So here you don't have to do that. Essentially, topics are created on a per message. Okay, so when a message comes in, if the topic doesn't exist, it gets created. But the nice thing is that you can start a subscriber into a topic that doesn't exist yet. So that's kind of nice, because it just makes it easy in terms of orchestrating the orchestration of starting up and bootstrapping of your system, and the order in which they come up. So I think that's pretty much it. There's this speaker deck from one of the creators of NSQ, which you probably should have a look if you're interested. And then this is the GitHub where the open source project is hosted. And that's it. If you have any questions, I'll be happy to answer. Otherwise, thank you for listening. Good. So, thank you all.